A useful way to understand artificial intelligence is to see how it has evolved over time. In this lesson, we will explore a timeline of key ideas, breakthroughs and challenges that have shaped the field from its earliest origins to the present day. Rather than appearing suddenly, AI developed through a series of important moments where new theories, technologies and approaches built on what came before. By following this timeline, you will see how early concepts about computation and reasoning led to modern machine learning and generative AI systems. This historical perspective helps us understand not only what AI can do today, but also why it works the way it does, and how the field continues to evolve. Before artificial intelligence became an official research field, early thinkers were already considering whether machines could perform tasks associated with intelligence. In the 19th century, Ada Lovelace wrote about the potential of Charles Babbage's analytical engine and argued that machines might manipulate symbols and follow complex instructions. Although this was long before electronic computers, her ideas helped establish the concept that machines could carry out structured reasoning processes. In 1943, Warren McCulloch and Walter Pitts proposed a mathematical model of an artificial neuron, and their work showed that networks of simple computational units could, in principle, perform logical operations. And this idea was important because it suggested that the structure of the brain might be approximated by computational models, a concept that later influenced neural networks and modern deep learning. In 1950, Alan Turing introduced the idea now known as the Turing test. Instead of trying to define intelligence directly, Turing suggested evaluating whether a machine could behave in ways that are indistinguishable from a human during conversation. This shifted the discussion from philosophical speculation to measurable behavior and helped motivate early work in language processing and conversational systems. In 1956, the Dartmouth Workshop formally launched artificial intelligence as a research field. Researchers gathered to explore whether machines could simulate aspects of human intelligence such as reasoning, problem solving and learning. Early symbolic AI systems focused on representing knowledge through logic, rules and symbolic structures. During the following decades, symbolic AI became dominant. Researchers built systems that attempted to represent knowledge explicitly and reason with it using logical rules. At the same time, contributions from researchers such as Karen Spark Jones helped advance information retrieval and natural language processing, particularly through statistical approaches to language and term weighting methods that later influenced search engines and modern language technologies. In the 1970s and again in the late 1980s, AI experienced what became known as AI winters. Expectations had grown faster than practical progress, and many early systems struggled when applied outside narrow domains. Funding decreased and enthusiasm cooled, but the period also encouraged deeper reflection on the limitations of rule-based approaches. During the 1980s, expert systems demonstrated that AI could still deliver practical value. These systems captured specialist knowledge using large collections of rules and were used in domains such as medicine, engineering, and finance. While effective in limited settings, they were difficult to maintain and could not easily adapt to new situations. In the 1990s, the field began shifting toward statistical machine learning. Instead of relying mainly on human-written rules, systems learn patterns from data. And this change made AI more adaptable and allowed researchers to tackle tasks such as speech recognition, handwriting recognition, and recommendation systems more effectively. In 1997, IBM Deep Blue defeated world chess champion Garry Kasparov. This event demonstrated the power of specialized computational systems and captured global attention. Although Deep Blue relied heavily on search algorithms and expert knowledge rather than modern machine learning, it symbolized the growing capabilities of intelligent machines. In 2009, the ImageNet dataset, developed by Fei Li and collaborators, enabled large-scale training of machine learning models. And this dataset provided the foundation for major advances in computer vision by making it possible to train models on vast amounts of labeled data. And in 2012, AlexNet achieved a breakthrough in the ImageNet competition and dramatically improved computer vision performance. And this success showed how powerful deep neural networks could be, when trained with large data sets and accelerated hardware. From the mid-2010s onward, deep learning expanded rapidly across many areas of AI, including speech recognition, translation, robotics, and natural language processing. From 2022 onward, generative AI entered mainstream public awareness. Large language models, image generators, and multimodal foundation models began supporting writing, coding, design, and many other tasks. This phase represents a shift from specialized AI systems toward broadly capable models that can generate content, assist decision-making, and interact with users in more natural ways.